Hi everybody, we're back and we are now going to talk about the factoring and equation solving that you need for the Common Core Algebra 2 Regents exam. And let's start us off with a song because you need to have structure when it comes to your factoring, and here it is.
Booking.com helps you find and book
That's not
just what
me.
you want.
So the first thing you look for whenever you're factoring is a GCF. In A, is there a GCF? No. Let's write it all out here. Factor. First thing you want to look for is a GCF. From there, if there's two terms, it's going to either be dots or cubes. Three terms is going to be a trinomial or a tricky trinomial. Four or more is grouping. And then you always want to ask yourself at the end, can you factor further? There's a formula for cubes at the end of the song, which we'll talk about. So, is there a GCF? No. Two terms, are they both perfect squares? Yes. Dots is always two sets of parentheses, plus and minus, square root of each, 6 and 6, 5x and 5x. B, is there a GCF? No. There are three terms, so it's a trinomial. Is it a tricky trinomial? No. Two sets of parentheses, x and x. First sign comes down, negative and a positive is a negative, multiplies to 12. Adds to 7, 3 and 4, bigger number comes first. C, is there a GCF? Yes. The GCF is 3. Always one set of parentheses for GCF. Can I factor further? Yes, it's a trinomial, x plus 4, x minus 1. Is there a GCF? Yes. One set of parentheses for GCF. Can I factor further? Dots, square root of each, x and x, 3 and 3. GCF comes out front. E, is there a GCF? No. Three terms, so it's a trinomial. Is it a tricky trinomial? Yes. Now there are two methods for tricky trinomial. I'm going to do them both. I'm going to start with the grouping method. The first term comes down and the last term comes down. I'm multiplying the first and the last. I need two numbers that multiply to negative 8 and add to positive 7. Well, that's positive 8 and minus 1. They each get an x. From there, I group it. 2x, x plus 4, minus 1, x plus 4. I combine my coefficients, 2x minus 1, x plus 4. That's how most people do it. However, with my students, I do it a little bit differently. I do what's called bridge method, so I'm going to erase that and now redo this with bridge method. Whenever I have a tricky trinomial, I want to build a bridge from my first to my last. Don't forget to pay the toll. I'm multiplying the first and the last. I factor the trinomial normally. I pay the toll. Whatever I divided by at the beginning, I divide by at the end. If it divides nicely, divide it. 8 divided by 2 is 4. If not, the variable goes in front, the denominator goes in front, and I get the same thing. F, is there a GCF? No. There are 4 terms, so it is grouping. So I pull up the GCF of the first group. I pull up the GCF of the second group. If there's a minus in front of the group, I pull out a negative. I combine my coefficient. I keep my like term. Can I factor further? Yes, that's dots. Plus and minus, square root of each, x and x, 3 and 3. The other x plus 3 comes down. Now we get into the more advanced factoring. You've never had to do any of this on the Regents unless it was multiple choice, in which case you can use multiple choice strategy, but I'll go over it anyway. It's more than 4 terms. First of all, is there a GCF? No. There's more than 4 terms, so it has to be grouping. So the group ends where the pattern of the exponents ends. So it's x to the third, then x to the second, then should come x to the first. Since it doesn't, that's the end of the group. It resets back at 2. If the first group has 2 terms, then they all have 2 terms. I take out the GCF for the first group, x squared, 3x plus 1. The GCF for the second group, because there's a minus in front, I pull a negative out, negative 4. Minus 21, 3x plus 1. These must match. They do. So now I combine my coefficients. X squared minus 4x minus 21, 3x plus 1. Can I factor further? It's a trinomial. First sign comes down, negative and negative's a positive, multiplies to 21, subtracts to 4, 7 and 3, and the 3x plus 1 comes down. H, I call this a substitution trinomial. It's a trinomial. There's 1, 2, 3 terms. It's something squared minus 11 something plus 24. So I'm going to replace that something with a single variable. I'll call it y. So it becomes y squared minus 11y plus 24. I factor the trinomial normally. First it comes down, negative and a positive is a negative, multiplies to 24, adds to 11, 8 and 3. Now I substitute back. I replace the y with x squared minus 2x for both of them. And now I factor each of them further. They're each trinomials. X and x. First sign comes down. Negative and negative is a positive. Multiplies to 4. Subtracts to 2. X and x. First sign comes down. Negative and negative is a positive. Multiplies to 3. Subtracts to 2. 3 and 1. Is there a GCF? No. 2 terms. Are they perfect squares? No. Are they perfect cubes? Yes. SOAP cubes. AB, A2, AB, B2. A cubed minus B cubed equals. The signs are SOAP. Same, opposite, always positive. So the first sign is going to be the same as the minus, then it's the opposite of that, and then it's always positive. To find a and b, I'm taking the cubed root of each. Cubed root of y cubed. Okay, hold on 1 second here. Here we go. Still frozen. Cubed root of y cubed is y. Cubed root of 125 is 5. And if you need to, you can go to your calculator to do cubed root, math 4, 125 is 5. So y cubed minus 125 equals a minus b is y minus 5. A squared is y squared. AB is 5y. B squared is 5 squared, which is 25. And that's it. Again, you've never had to do either of those last 3 types of factoring. Open response, they've only come up multiple choice where you could use multiple choice strategy. Could it come up open response? It sure can, but it hasn't. Now we move into equation solving for polynomial equations. Mr. X to the third, just like Mr. X squared, he wants to party. Before he can party, all of his friends have to come over. To solve a polynomial equation, bring everything to one side. Party time. Once you bring everything to one side, they want to party with bubbles. Bubbles mathematically means factor. Factoring mode. Is there a GCF? No. There are 4 terms, so it's grouping. Pull out the GCF of each group. X squared is the GCF of the first group. Negative 4 is the GCF of the second group. Combine the coefficients, keep the like term. X squared minus 4, x plus 5 equals 0. Factor it further. Square root of each, x to 2. The x plus 5 comes down. That was a little too sloppy. And now I set each factor equal to 0. I set x plus 2 equal to 0. I set x minus 2 equal to 0. I set x plus 5 equal to 0. And those are my 3 answers. So for a polynomial equation, bring everything to one side. Factor, set each factor equal to 0. To help you remember that, Mr. X squared, Mr. X to the third, he wants to party. Before he can party, all of his friends have to come over. Then they party with bubbles, which are parentheses, which are a product of factoring. Mr. X squared, again, he wants to party. Before he can party, all of his friends have to come over. Are all of his friends over right now? No. I add 8 to both sides. I get x squared plus 2x plus 8 equals 0. Party time. You want to party with bubbles. However, are there 2 numbers that multiply to 8 and add to 2? No. Bulb machine's broken. He's got all of his friends over ready for a party. What does he do? Well, he busts out his guitar and he sings his song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If it's a quadratic that you cannot factor, that's when we use the quadratic formula. List your a, b, and c values. Substitute in. Negative b means change the sign of b. And make sure that your b goes in parentheses. This is given to you on the reference sheet. X equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 8 all over 2 times 1. Type in what's inside the radical into the calculator. Don't type the radical itself, just what's inside the calculator. And now this is where students tend to get messed up. Next step, off to the side, reduce the radical. Negative inside the radical becomes an I. And then to reduce it, I want to break it down to my perfect squares and non-perfect squares. Perfect square goes first. 4 is a perfect square that goes into 28. It gives me 2i radical 7. So now I rewrite it. Negative 2 plus or minus 2i radical 7 over 2. Now I break it apart. Negative 2 over 2 is negative 1. 2i rad 7 over 2. The 2's cancel. I get I radical 7. And that's my answer. If it's a quadratic that doesn't factor, that's when you do the quadratic formula. Sub your values in. And again, once you get to this point, pop it off to the side and reduce the radical. At the end, if there's an I involved, you have to break it apart. I see a radical equation. First step in a radical equation is to isolate the radical. Is the radical by itself right now? No. So I'm going to subtract x from both sides. 5 minus x is 5 minus x. Now that I'm isolated, to get rid of the radical, I do this. I square both sides. On the left-hand side, the square and the radical cancel, and I'm left with 2x minus 7. On the right-hand side, 5 minus x squared, well, that's 5 minus x times 5 minus x. And to do that, I have to do my box method. You could also use square binomial theorem, which is a plus b squared equals a squared plus 2ab plus b squared. But most students use the box. Mr. X squared, he wants to party. Before he can party, all of his friends have to come over. Party time, bubbles. There is no GCF. It's a trinomial. First sign comes down, negative and a positive is a negative, multiplies 32, adds to 12, 8 and 4. Set each factor equal to 0. X is 8, X is 4. However, this is not the correct answer because I have to check a radical equation for extraneous solutions. Not that I made a mistake. I mean, I could have made a mistake, but you have to check to make sure your answer works. I'm going to do it by storing. I'm going to store x for 8. I'm going to type in radical 2x minus 7 plus x. I'm going to type in the right-hand side. Does the left-hand side equal the right-hand side? No. I reject that one. It's not a solution. It's called an extraneous solution. It's not an answer. Now I got to check 4. So I'm going to do 4 store as x. I'm going to copy the left-hand side. I already typed it. I'm going to type in the right-hand side. Does the left-hand side equal the right-hand side? Yes. That is the answer to the problem. For radical equations, isolate the radical. Square both sides. You might have to do some nasty algebra like boxing it out. Follow your Mr. X squared story. If a quadratic comes out, everything to one side. Factor, set each factor equal to 0, and you must check. A fractional equation. To solve a fractional equation, I want to multiply by the LCD. To get my LCD, I list all my factors and all my denominators. I see an x, I see an x plus 2, so my LCD is x parentheses x plus 2. So I'm multiplying everything by the LCD. X's cancel, x plus 2's cancel, x plus 2's cancel. What am I left with in my first fraction? 3 times x plus 2. In my second fraction, x squared. In my third fraction, negative 2x. Fractions gone. Now I just let my algebra skills kick in. Distribute. Mr. X squared, he wants to party. All of his friends have to come over. I'm going to rewrite this in standard form. X squared plus 5x plus 6 equals 0. I factor. And I set each factor equal to 0. I get x equals negative 3. I get x equals negative 2. I'm not done. Just like radical equations, I have to check. All I really have to check for is to make sure that my answers are not going to make the denominator 0. Will substituting negative 3 make any of my denominators 0? No. Will substituting negative 2 make any of my denominators 0? Yes. If I put negative 2 in for x, I would get negative 2 plus 2, which is equal to 0. I can't have that. Negative 2 is an extraneous solution. Negative 3 is my only answer. Now again, if you have no algebra skills, refer back to the previous video. Y1, Y2, intersect. In fact, I'll do it quick. For those of you watching this being like, oh my god, I can't do that. Oh my god, I'm not going to get any points. Oh my god. Don't worry about it. Take the 2 points using Y1, Y2 intersect and move on with your life. First of all, as far as showing work goes, and this applies to everything we're doing in this video pretty much, any equation, write y1, y2 intersect, y equals alpha, y equals enter, 3 over x plus x over x plus 2 negative 2 over x plus 2 zoom 6, whoops, zoom 6. They look kind of funky, these fractional equations. If you can't see what's going on, it'll find it. Second trace, option 5. Looks like it's going to hit over there. Enter, enter, enter. Again, it's always the x solution. X equals negative 3. That's 2 points. As opposed to how we did it algebraically, which would be 4 points. Obviously, we'll take the 4 points, but if you don't have those algebra skills, get your points. Number 57. Solve algebraically for x. This is a fractional equation. I'm sorry, this is not a fractional equation. This is an exponential equation. The first step in an exponential equation is to isolate the base. Subtract 12 from both sides. Divide by 3. I would leave it as 88 over 3 for now. To solve variable exponential equations, I do the log of both sides. I'm literally writing log in front of both sides, and the reason I do that is the exponent comes down in front. Now, to deal with this fraction, we just learned how to solve fractional equations. I'm going to multiply by 2. X log 1.2 equals 2 log 88 over 3. Divide by log 1.2. Divide by log 1.2. I pop that into the calculator. It should say what to round to. I guess I didn't say what to round to. Sorry. They will say on the regions what to round to. I'll just choose to round to the nearest tenth. 2 log, why am I in y equals? I don't know. Alpha y equals enter. 2 log 88 over 3 over log 1.2. If I want to the nearest tenth, that would be 37.1. So to solve a variable exponential equation, if there's a variable in the exponent, isolate the base, log of both sides, variable comes in front, isolate from there. This is another exponential equation. First step is the same. Isolate the base. The x is what's being raised to the power, so I have to divide the 2 away. Now this is a constant exponential equation. There's no variable in the exponent. There's a constant in the exponent. So to solve a constant exponential equation, I raise both sides to the reciprocal power. 4 to the power of 3 halves. It's good if you know that 4 to the power of 3 halves is the power over the root, square root of 4 to the third, 2 to the third, which is 8. But if that just confused you, that's okay. 4 to the power of 3 halves is just systems of equations. Not many shortcuts you can do here. Step 1, you need to have a variable by itself in at least one equation. Well, y is by itself already. So I'm going to substitute one equation into the other. So I am going to replace the y with x plus 2. That's step 1. Now I'm going to combine like terms. 2 minus 4 is negative 2. And now, because I have 2 square binomials, I'm going to have to do 2 boxes. So I got x plus 2 times x plus 2. I've got x minus 2 times x minus 2. X squared plus 2x plus 2x plus 4. X squared minus 2x minus 2x plus 4. x squared plus 4x plus 4, x squared minus 4x plus 4. So it's x squared plus 4x plus 4 plus x squared minus 4x plus 4 equals 40. Combine like terms, 2x squared, positive 4x and negative 4x cancel, 4 and 4 is 8. Mr. X squared, he wants to party. Before he can party, all of his friends have to come over. Party time, bubbles, factoring. First thing I look for in factoring is the GCF. If it's an integer GCF, I can just divide it away and it's gone. Factor further, dots, plus and minus, square root of each, x and x, 4 and 4. Set each factor equal to 0. Set each factor equal to 0. I got x equals negative 4, x equals positive 4. Now, I'm not done because the system has x values and y values. So I'm going to take one of the original equations, whichever one is easier, and I'm going to substitute my answers in. Y equals negative 2, y equals 6. So my two answers are negative 4, negative 2, and 4, 6. Substitute one equation into the other. Do the algebra, do the Mr. X squared, get your x values. Once you have your x values, substitute each of them into one of the originals to solve for the other variable. So earlier, or in the other video I should say, we talked about matrix method to solve 3x3 systems. Well, this one we're going to do algebraically. We're going to do elimination method. It's long, but whatever. I'm going to label A, B, and C. I'm going to choose a variable to cancel. I'm going to choose the y's to cancel because looking at this right here, those are going to cancel without any work. That's what I'm going to start with. I'm going to start with A and B. X plus 2y minus 3z equals negative 2. 2x minus 2y plus z equals 7. If I add them together right now, the y's are going to cancel. 3x minus 2z equals 5. I call that equation B. Now I'm going to choose another pair of equations and get the same variable to cancel. I'll do a little bit more work for this one, but that's okay. I'm going to choose B and C since the y's are different signs. So I've got 2x minus 2y plus z equals 7. I've got x plus y plus 2z equals negative 4. If I multiply them together right now, if I add them together right now, nothing's going to cancel. So I multiply by the other's coefficient. The signs are different. That's good. So I keep everything outside positive. I multiply everything through. 2x minus 2y plus z equals 7 on top. On the bottom, 2x plus 2y plus 4z equals negative 8. When I add them together, my y's cancel. I get 4x plus 5z equals negative 1. That's equal. Now, I take D and E, and I do a 2x2 system. So I've got 3x minus 2z equals 5. I've got 4x plus 5z equals negative 1. I'm going to choose a variable to cancel. I'm going to get the z's to cancel since they're different signs. I keep everything outside positive. Multiply everything through. 15x minus 10z equals 25. 8x plus 10z equals negative 2. Add them together. 23x equals 23. Isolate x. X is 1. Now I stick with the 2x2 system. I write one of the originals. 4x plus 5z equals negative 1. I replace the x with negative 1. And I do the algebra. I solve for z. Z is negative 1. So x is 1, z is negative 1. I have 2 of the 3 variables. Now, my computer freezes again. So now I take one of the originals. Let's do the bottom one, looks the easiest. X plus 2y, x plus y plus 2z equals negative 4. I'm going to replace my x with 1. Y is what I'm trying to find. Replace my z with negative 1. 1 plus y minus 2 equals negative 4. Combine like terms. Add 1. Y equals negative 3. Those are my answers. That's 4 points. And just a refresher of your other option, which would get you 2 points, which we talked about in the previous lesson, in the previous video, excuse me. Second matrix, edit, A, input the coefficients, 1, 2, negative 3, 2, negative 2, 1, 1, 1, 2. Second matrix, edit, A, 3 by 1 always, negative 2, 7, negative 4. Second quit, second matrix, A, inverse, same button without hitting the second button, B, there are your answers. All right, if it says to do it algebraically, which it will as a 4-point question, to get your 4 points, you need to do it algebraically. If you do it with the matrix method and you write x, y, z equals A inverse B, you could get 2 points. And if it's multiple choice, use matrix method. Am I getting close to the end of this thing here? A car that was bought for $24,320 after $9,200 is worth $9,200 after 7 years. Well, we dealt with this. We dealt with these formulas in the previous video. Let's just talk about them again quick. I guess we can play our song again. Why not? Here, enjoy. Principal parentheses, 1 plus or minus the rate to the power of time, 5, 3, by 100, yo. Principal parentheses, 1 plus minus r over n to the power n(c), compound for continuous, converting rate, 1 over n, half-life rate t over h, irregular, converting rate, 1 over n, half-life rate t over h, regular. Principal parentheses, 1 plus or minus the rate to the power of time, divide the rate by 100, yo. Principal parentheses, 1 plus minus r over n to the power nt, compounding per for continuous, converting rates, raise 1 over n, half-life raised t over h, irregular. Irregular time also has the exponent of t over h. If you see compounding, we use our n formula. Unless it says continuously, we use per. Half-life, we use the half-life formula. And irregular, meaning that we are increasing by 5% every 2 years or every 3 years, that's when we use the irregular formula. If we don't see either of those things, that's when we use our regular exponential modeling. So, a car that was bought for $24,320 is worth $9,200 after 7 years. To the nearest percent, what is the annual rate of depreciation? I don't see compounding. I don't see continuously. I don't see half-life. There's nothing irregular. This is my regular standard formula. A equals P equals R equals T equals. a car that was bought for $24,320. Well, P is your initial amount. A is your after amount. After time has passed, it's now worth $9,200. Time is 7. The rate is what I'm trying to find. So I've got 9,200 equals 24,320. Because it's depreciation, it's getting smaller. It's 1 minus the rate to the power of 7. Now I have to solve the exponential equation, so I divide both sides by 24,320. 9,200 divided by 24,320 is 0.378 equals 1 minus r to the power of 7. This is a constant exponential equation. We're not going to do logs because there's no variable in the exponent. It's a constant, and to solve constant exponential equations, I raise both sides to the reciprocal power. You could also have done the 7th root of both sides. Both things are equivalent. So I'm going to take that and I'm going to raise it to the power of 1 over 7. I get 0.87 ... equals 1 minus r. Well, I don't want 1 minus r, so I'm going to subtract 1 from both sides. Negative 0.129 ... I don't want negative r, I want positive r, so I divide by negative 1. And that's going to give me 0.129 ... Now, that's the rate as a decimal. It wants it to a percent. So to make that into a percent, I now multiply it by 100. And I get to the nearest percent, 13%. So you have to know your formulas, and if you're solving for r, you're going to end up solving a constant exponential equation. Once you isolate, you're going to raise both sides to the reciprocal power and solve from there. And it will generally ask you for a percent if they give you this question. Once you get your decimal, once you get r by itself, you'll have to multiply by 100. 62. Susie invests $500 in an account that is compounded continuously. Compounding PERT for continuous. That's my formula. A equals PE to the RT. A equals P equals R equals T equals. She invests $500. That's the initial or starting amount. The rate is 5%. Don't forget to divide the rate by 100, yo. Approximately how many years will it take for Susie's money to double? Well, if her money is doubling, her after amount is going to be 2 times her initial amount, which would be 1,000. So if it says double or triple or whatever, you have to multiply the initial amount by 2 for doubling or 3 for tripling, and that will be your after amount. It wants to know how many years. So approximately how many years, I'll just round to the nearest year at the end. So I replace my values. 1,000 equals 500 e to the 0.05t. And now I need to solve the equation. Isolate is my first step in any exponential equation. And now, since this is a variable exponential equation, I do the log of both sides. We could do log of both sides. We could do ln of both sides. I'm just going to do log of both sides. I feel like for my students, it's less confusing. Log 2, the exponent comes in front, 0.05t log e. To get the t by itself, I divide both sides by 0.05 log e. I go to my calculator, alpha y equals enter. Log 2 over 0.05 log second e. And again, it should say what to round to. I didn't, so I'll just round to the nearest year. T equals 14. When you're finding t, you're going to have to do log of both sides, but again, you need to know your exponential modeling formulas, or else you're not going to get very far. One of the medical uses of iodine. We saw something very similar to this earlier. It's really the same problem, it's just a different ending. The half-life. Half-life raised t over h. Write down the formula for half-life. A equals P equals T equals H equals. The half-life is 8.02 days, so H is 8.02. A patient is injected with 20 milligrams. That's your initial amount. Determined to the nearest day. It's asking for time. The amount of time needed before the amount in the body is 7. Let's talk about the difference between A and P and T and H. A is your after amount, the amount after time passes. After time passes, there's 7 milligrams left. P is your initial amount, the amount before time passes. She was initially injected with 20. P is the initial, A is the after. T and H. T is the time that's actually passing. H is the time it takes for it to be cut in half. So I substitute my values in. 7 equals 20. 1/2 to the t over 8.02. That's a little too close. I don't know why I always do that. Let me just create a little bit more space here. 7 equals 20. 1/2 to the t over 8.02. It's a variable exponential equation. First step is to isolate the base. Leave it as a fraction. 7 over 20 equals 1/2 to the t over 8.02. Now, log of both sides. Since I have a variable in the exponent, I get log of 7 over 20 equals t over 8.02 log 1/2. Remember, the exponent comes in front when you're doing logs. I don't like this fraction, this 8.02 on the bottom, so I'm going to multiply both sides by 8.02. I get 8.02 log 7 over 20 equals t log 1/2. Divide both sides by log half. T equals alpha y equals enter 8.02 log alpha y equals enter 7 over 20 over log alpha y equals enter 1/2. It says to the nearest day, that would be 12. So again, it's knowing your formulas and then knowing your algebra. So this section, we talked about the equation solving at the beginning of this video. Now we're applying the equation solving to the actual problem. I don't know what I just did. No problem. 64. This incorporates something that we talked about in the previous video. Find a value of k such that x plus 3 is a factor. Well, if x plus 3 is a factor, that means that negative 3 is a 0. That's the connection you need to make, which means that negative 3 comma 0 is on the graph. So to find a missing value, I can replace p of x with 0 and x with negative 3. And then do the algebra to solve for k. Just a linear equation, combine like terms, isolate, add or subtract first, divide last. K equals negative 19. That's the first part of the question. So, p of x equals x cubed minus 19x minus 30. Now it says to find all the zeros. So replace p of x with 0, and then I have to factor this. I can't factor this. It's not a trinomial. There's nothing I can do. So the only way to factor something that doesn't factor is to know one of the factors already. And I do know the factor already. I know that x plus 3 is a factor. So I'm going to divide the polynomial by x plus 3 using synthetic division. List my coefficients. There's a missing term for the x squared, so I put a 0 in its place. The opposite of what I'm dividing by goes outside. First one comes down, multiply, add, multiply, add, multiply, add. It will always be the case, if it's a factor, that the remainder will be 0. So now I'm going to rewrite this as x plus 3 times x squared minus 3x minus 10. I can factor it further. It's a trinomial. I wouldn't say, this has been on my commonly asked question thing for a while. This doesn't come up that much anymore. I'm on the fence of removing this, but it's still here. It could come up. But out of all the things we're going over here, I'd say this is a lot lower priority than like everything else we've done in this video. Probably the lowest priority. That being said, if it comes up as a 4-point question, then it's going to be pretty damn important. Those are your answers. So I had to substitute negative 3, 0 in for x and p of x to solve for k. Once I had that, I had to divide out the factor that they told me using synthetic division. Then I factored further and set everything equal to 0 to find the zeros. Am I done yet? Last question. And it's the commonly asked 6-point question. The value of Tom's bank account is currently 100,000 and is decreasing according to the equation V of t equals. The amount of money he has paid for his mortgage can be represented by M of t equals. Graph and label them. To graph anything, that's easy. I go to my calculator, I type it in, I plot the points. V of t is 100,000. 0.876 to the power of x, and then m of t is 20,000, 1.1304 to the power of x. Does it say what to graph between? Yes, it says to graph between 0 and 10. So I'm going to make a table for v of t and for m of t. I'm not going to plot every single point. I'm thinking a little 0, 2, 4, 6, 8, 10 action. Zero, let's do the v of t first. 100,000. This is going to be a little bit of pain. You know what I'm going to do to save some time? I mean, listen, you can see the values there. I have them written down on my paper, so I'm just going to pull them off my paper. No, I don't have them on my paper. Well, that's great. 100,000, 76,738, 5,887, 6 is 45,188. 8 is 34,676. And 10 is 26,610. M of t now, kind of work backwards, 68,132. 8 is 53,320. 6 is 41,728. 4 is 32,656. 2 is 2,556. And 0 is 20,000. Now I need a scale. I'm going to do it for x and for y. Your scale is greater than or equal to your max divided by your number of boxes. And that applies for both of them. So for my x, the highest x value I have is 10. My number of x boxes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Ten divided by 20 is 0.5. So it must be something that's greater than or equal to 0.5. Is 0.5 a nice value for my x's? Yes. Because if every box is worth 0.5, it means every other box is worth 1. So I label those. For my y's, my maximum value in my table is 100,000. And there's also 20 y boxes. 100,000 divided by 20. It must be greater than or equal to 5,000. It's not going to always work out to be a clean number. I need to choose something that's bigger than greater than or equal to this number. The closer it is to the number, the nicer the picture is going to look, but I want it to be easy to work with. This particular one, 5,000, is very easy to work with, so I'm going to stick with that. But I'm not going to label every box because that's going to get messy. I'm just going to label every other box as 10,000. So that's 10,000, 20,000, 30. This is even getting a little scrunched as it is. 40,000, 50, 60, 70, 80, 90, 100. That got a little scrunched, sorry. Now we plot the points. Let's do v of t, 0, 100,000, 2, 76. It does not have to be exact, but it should be in between the appropriate boxes. 4 is 58,000, so a little bit less than 60,000. It is hard to do it on this little grid here. It's a little bit easier for what you have, but we'll get by. 6 is 45, so a little bit more than the 45. 8 is 34, a little bit less than the 35, and 10 is 26. Boom. No arrows, since it gave me an interval. I'll label that v of t. I'm going to use a different color. I'm going to do m of t. 0 is 20,000. 2 is a little over 25,000. 4 is 32,000. 6 is 41,000, a little bit more than 40. 8 is 53. A little bit less than 55. 10 is 68. And that's your m of t. So to graph something, I mean, come on, just type them into the calculator, type into y equals, pull the points from your table of values and plot them. Follow-up questions. They almost always ask the same follow-up questions. First follow-up question almost always is the intersection. Let's see if that's what it's asking here. I have room to actually do this. Let's see. That'll work. After how many years will the value of Thomas' bank account be equal to the amount of money he paid for his mortgage? Round your answer to the nearest tenth. It's asking for the intersection. I can't determine the exact tenth based on the graph. So I'm going to do my y1, y2, intersect. I'm going to pull my window from the graph. By graph, if I go to window, my x values are going from 0 to 20. So my x min is going to be 0, and my y max is going to be 20. My y's are going from 0 to 100,000. I already did all the work to create my scale, so now I can just input them and see it from there. And you'll see the same thing on your screen that you see in your actual graph. To find the intersection, we've dealt with this in the previous video quite a bit. Second trace, option 5. Move the cursor to the point of intersection. Enter, enter, enter. And the answer for y1, y2 intersect is almost always the x-coordinate. X-coordinate, x-coordinate. It's asking how many years. That's t, that's x, 6.3. So I would say y1, y2 intersect. That's you telling the grader what you did, 6.3. Tom will open a new bank account when the value of his account is 30,000. Value of his account is 30,000. Value of his account. V of t is the value of his account. So we are going to replace V of t with 30,000. I'm going to get 30,000. Of course I'm free. So I'm replacing 30,000. Sometimes it just takes a moment. So I'm replacing 30,000 for V of t equals the 100,000.876 to the power of t. So I'm just going to pull that onto a new slide here. So I've got 30,000 equals 100,000.876 to the power of t. I'm going to solve it two ways. Does it say to solve it algebraically? Well, it's kind of hidden at this point, because does it say to solve it algebraically? No. So I can just do y1, y2 intersect. So I can just get rid of the second one because that doesn't matter anymore. 30,000. Second trace, option 5. Enter, enter, enter. It said to the nearest hundredth of a year, 9.09. And that would get you full credit since it did not specify to do it algebraically, and you writing y1, y2 intersect would be you showing your work. Now I will do it algebraically, because, this is supposed to be an algebra video. So to solve this equation, step 1, isolate the base, divide both sides by 100,000. 30 over 100,000. Alpha y equals enter. 30,000 over 100,000 is 3 over 10. Now that I isolated the base, to solve a variable exponential equation, I do the log of both sides. The variable comes in front. Log of 3 over 10 equals t log 0.876. Divide away the log 0.876. Go to the calculator. Alpha y equals enter. Log alpha y equals enter. 3 over 10 over log 0.876. And I get to the nearest hundredth, 9.09. And that should be what I got when I did alpha y equals enter. I didn't write it down. Yep. And that's it. So this video is all the algebra skills that you need in order to be successful for the Algebra 2 Regents. We started off with factoring. When you're factoring, is there a GCF at the beginning? Can you factor further at the end? In between that, 2 terms is either dots or cubes. 3 terms is a trinomial or a tricky trinomial. 4 or more is grouping. To solve polynomial equations, everything to one side. Factor, set each factor equal to 0. If it doesn't factor, that's when you use the quadratic formula. Radical equations, isolate the radical, square both sides, check. Fractional equations, I know I kind of pulled the workout, but multiply by the LCD, solve the equation, check. Variable exponential equations, isolate the base, log of both sides. Constant exponential equations, isolate the base, raise both sides to the reciprocal power. Quadratic systems, substitute one equation into the other, solve for x, do the algebra, do your Mr. X squared, solve the quadratic equation. Once you get your 2 answers, substitute each of them into one of the originals to find the other variable. 3 by 3 systems, choose 2 pairs of equations and get the same variable to cancel for both. Take the resulting 2 by 2 system, solve that, sub into one of the originals for the third. Then we incorporate the equations into our modeling. You need to know your exponential modeling formulas. Once you sub everything in, this one was a constant exponential equation, so we raised the reciprocal power. This one was a variable exponential equation, so I did log of both sides. Another variable exponential equation, log of both sides. It told me that x plus 3 is a factor, so I concluded that negative 3 was a 0. I used that to find k. From there, to solve this polynomial equation that couldn't be factored, I had to divide out the given factor using synthetic division and factor it further. And then, of course, set each factor equal to 0. And finally, the 6-point question, which really wasn't that much equation solving. At the very end, there was some equation solving, which we didn't have to do. We could have done y1 and y2 intersect. But if it tells you to graph something, just graph it. Once you graph it, the first follow-up question is going to almost always just be to find the intersection point using y1, y2 intersect. And the final follow-up question is that they're going to usually give you a value. You substitute into the proper spot, and then you do the algebra or your y1, y2 intersect. In this case, doing the algebra, since again it was a variable exponential equation, we did log of both sides. Most commonly, you're probably going to see a little bit of all of this, but you're almost definitely going to see a variable exponential equation, so make sure you're able to do that. And I keep on saying refer back to the other video for everything else. There might be a problem with the other video. I'm not sure if it recorded correctly, so we'll see what happens with that. But this one is done. I am done. Practice. Have a good day.